Okay, this little video clip is based on rates of reaction, okay, which is a new topic that we're going to be starting, and we're going to go through what's the theory behind it, okay. So, why study rates of reaction? Why is it important? Well, two reasons really, okay. If you're thinking about the manufacturing of compounds, which is an important part of any society, the rate of the reaction is definitely going to affect the economic factors, isn't it? Which is about making money and profits from the process. And there's also safety concerns as well. If a rate of reaction is going too fast, it could let off too much energy and you risk of explosions and damage to property into life. So it is an important issue. So what are our learning outcomes today? Well, hopefully by the end of this session you'll be able to describe how to determine the rate of a chemical reaction. Describe how chemical reactions occur using collision theory, which is the theory that you would always use when answering any exam questions on rates of reaction. And also define the term activation energy. So, how can we measure the rate of reaction? Okay, and there's two main ways you could do it. The first one is you could measure how quickly the product is formed from a chemical reaction, okay, over a certain time period. So it literally would be the amount of product formed divided by time could give you the rate. And if we'd done a graph of that, it would look something like this, okay? Because obviously at the beginning of the reaction, there'd be no product formed. And then as the reaction goes on, the amount of product formed increases, okay? The other way we could do it is measure how quickly the reactants are used up, okay? So, same thing again. The amount of reactant would be divided by time and that would give you the rate. And if we looked at that as a graph, obviously the amount of reactant would be very high at the beginning of the reaction. And as the reaction proceeds, the amount of reactant gets less. Okay. So, what is collision theory? Well, quite simply, in order for things to react, they've got to collide with each other. There's got to be some sort of contact between the reactants to initiate a chemical reaction. Okay. Will any collision work? Well, the short answer is no, it won't. In fact, most collisions don't lead to a chemical reaction. And that's really down to three main factors. The activation energy, which I'm going to talk about in a minute. The wrong type of collisions, okay, only a very specific type of collision will initiate a chemical reaction. And another important one, which isn't on the AQA spec, is orientation of the collision. So, what is activation energy? Okay, well, if you think of it like this, I've got a Bunsen burner hooked up here. I've turned on the gas supply, and we're now pumping out methane gas, and it's colliding with the oxygen in the atmosphere, but we haven't got a chemical reaction, okay? In order for that chemical reaction to occur, I have to put a little bit of energy in, okay? If I do that, then we get combustion, okay? So in this case, the activation energy was the flame from the lighter, and once that energy was given, the reaction was able to proceed, okay? So really, what is activation energy? Well, it's the minimum amount of energy to initiate a chemical reaction. And what do I mean by initiate a chemical reaction? I actually mean initiate bond breaking, because obviously all chemical reactions involve bond breaking, and bond making. And this is a graphical representation of it, which I'm not going to get too bogged down with at the moment. We're going to look at that later on in the topic. The different types of collisions, okay? Well, it could collide with another molecule of itself. Obviously, if it's colliding with another reactant, the wrong reactant molecule of itself, it's not going to initiate a reaction. It could collide with the sides of the container, obviously, which again wouldn't lead to a chemical reaction. It could collide with insufficient energy, and that links into my previous point on activation energy. And obviously, one end of the molecule could be the reactive end of the molecule, and if it doesn't get a collision at that end of the molecule, that could affect the rate of reaction as well. So the thing to remember is most collisions do not lead to a chemical reaction, okay? Only collisions which fulfill all the criteria will be successful collisions. And what I'm calling a successful collision is really one that will initiate a chemical reaction. So, what are the 4 things that can affect the rate of a chemical reaction? Well, there's 4 things. One of them is the temperature of the reaction. Another one is the concentration of the reactants, the surface area of the reactants, and a catalyst. Okay, you might have come across this term before, but we'll explain that later on in the course. So, to summarise, to bring this all together, okay, how do we link what we've talked about in collision theory to actually explain how one of these factors increases the rate of reaction? In this example, I've gone with increasing the concentration, okay? So if you think about it, if you increase the concentration of something, you put more particles in per unit volume, okay? So if there's more particles in an enclosed space, that's going to lead to more collisions within that space. And if you're increasing the number of collisions, well, proportionally speaking, that would lead to more successful collisions. And if you increase the number of successful collisions, that would then increase the rate of reaction. Okay, I hope you find this video clip helpful. I'd like you to have a go at the questions on the sheet. Thank you.